The first thing I need to do here is on the page 48 of the notes is to point out a typo. This says when using shell method with a should be horizontal axis, the functions must be in terms of y. So that's what we're going to do. We're going to learn how to use shell method when rotating about a horizontal axis. So to get a picture of this function, first thing we're going to do is graph it. So this is y equals root x, and if you plug in some x values, you'll find that 1, 1 is on there, and also 4, 2 is on the graph, as well as 0, 0. And so our graph looks something like this. And the region we're going to find is the one between this graph, x equals 0, which is the y-axis, and y equals 2, which is that line there, the horizontal line. So in fact, this is the region that we're going to take and spin around the x-axis. Okay, so switching to red, what we get is something like that. And in blue, remember what we do is we now, this is actually up here at height 2. So what we do is we pick now a y value, because what we need to do is find the cylinder, right, that we'll obtain. So this is the quote-unquote height of the cylinder, and there's the cylinder, which has radius. It looks like just the y value itself, right? If y is like, let's say, something bigger than 1, what it looks like here, that's exactly the radius. So the part that's forming the circle will be the radius. And now the height of the cylinder looks like it's just given by the function y equals root x. So let's start to set this up. I'll have one remark to make before we do that. So the y bounds on the region class are 0 to 2, 2 pi, y is the radius, and now we need to multiply by the height, which it is the square root of x, but we need everything in terms of y. So this is actually x equals y squared, right? And so that's what goes there. It needs to be in terms of y. All right, so this is just now integral 0 to 2, 2 pi times y cubed. And so integrating, increase the power, divide by the new power. So you get pi y to the 4 over 2. Plug in 2. 2 to the 4th is 16. Divided by 2 is 8. So it looks like we're going to get 8 pi minus, and then plug in 0. Everything's gone. So that's just 8 pi. All right. I guess I could write more concisely what's happening here. So if you want, maybe put this in your notes. But using quotes, we'll say that shell method plus horizontal axis. Well, what that requires is functions and limits of integration. Have to be in terms of y. So it's totally backwards from disk-washer method, which in some sense is, easier because now, like, you hopefully won't confuse the two methods when one is required over the other. Okay, so what we're going to do is now we're going to take the same curve, y equals square root of x. Notice we're going to find the region under the curve and bounded by x equals 0, which is the y-axis, and x equals 1, which is the vertical line at x equals 1. So here is the square root of x. 1, x equals 1 is forming our right region here. The square root of x goes from 0, 0 to 1, 1. And it's the region under this curve, class. So it's tempting. Notice the difference between this problem and the last. Here the region was like, well, not under the curve, it was sort of above it, whereas here the region is under the curve. And we're going to take this and we're going to spin it about the x-axis. And so our first observation should be, oh, well, I have a horizontal axis and I'm supposed to use shell method, so I need everything in terms of y. Well, what that tells me now is then that x equals y squared. Just change that, right? Okay, so now let's see if we can determine what the cylinder will look like. Well, pick a y value in our y range. This is y goes from 0 to 1. Now the cylinder will have this height here, which we'll get to in just a minute. And then when we spin it, we get something that looks like this, right? Okay, so now our volume is going to be the integral over the y bounds, 0 to 1, 2 pi radius. Well, the radius of this cylinder here is just y itself. And the quote-unquote height of the function, so I'll make this a square bracket, the height of the cylinder, well, it's no matter where y is, you actually have an upper bound of 1 everywhere. So that's sort of like your upper minus, now your lower is being formed by x equals y squared. So this one's a little bit trickier to see, but if you just put y squared as the height, that would only be giving you this length here. But we want 1 minus y squared, right? 1 is sort of the upper, it's farther to the right, minus lower, which is farther to the left. Okay. And so distributing here, we get integral 0 to 1, 2 pi, it looks like y minus y cubed. Antiderivative is 2 pi y squared over 2 minus y to the 4 over 4. Plugging in 1, looks like we get 1/2 minus 1/4 minus parentheses, plug in 0, and everything goes away. So 1/2 minus 1/4 is just 1/4 times 2 pi is pi over 2. Okay, in the next video we'll be covering the last page of notes. And then just like section 7.2, we'll also have a little extra practice with some problems.